We start off with our first class on the chapter Permutation and Combination. And in this class, we are going to start off with the basics. Basics in the sense we are going to start off with the idea of the underlying idea behind permutation and combination. So in most of the cases, people don't teach this part, they just directly skip into the topic. So let us just see how these underlying principle works, and from there we are going to go straight into the topic of permutation and combination in our next classes. Okay, so the first thing that we are going to discuss is fundamental principle of counting, and the second thing is factorials. Now, to begin with, fundamental principle of counting, there are two different principles. The first one is called the principle of multiplication, the second one is called the principle of addition. The first one is, if an event occur in m different ways, and if when it has occurred a second event is occurring in n different ways, then the both of them can occur together in m into n ways. So now you can see this, I have marked this in bold, and means both happening together. Fine. And then in the second case, principle of addition, if both the events are occurring in such a way that there is nothing common between them, then either of them can occur. Either of them means in either of them, either or any one of them can occur in m plus n ways. Fine. So to give you an example, the idea is, if I am going from A to B, I am going from A to B in three different ways, and from B to C in two different ways, then what is the total number of ways I can go from A to C? Obviously, I can go in 6 different ways. Fine. Now again, if I have, say, from A to B, I can go by different means of transport in 3 different ways. I can walk to B from A, so that is one different way, and also I can catch a train and I can go to B, so that is another different way. So you see, all these different ways of going from A to B, there is nothing common between them, because in case of 3, I'm talking about road transport. So this is road transport, this is rail, and obviously this is walking. Now in all the different cases, there is nothing common between them, because they are all different kinds of transport. So therefore, what are the ways of reaching B from A, or what are the different ways of reaching B from A? That is 1 plus 3 plus 1, that is 5 ways. Fine. So this is giving you the rough idea of how principle of addition and principle of multiplication works. To give you a better idea, always remember that principle of multiplication works in the same case. If you are having the same case, when you are doing the work simultaneously in the same case, then you multiply. But if you have a different case, then you add. Fine. So let us take few problems and understand how these works. Number 1, the first one, how many 3-letter code words are possible using the first 10 letters of English alphabet? Now the idea is, you are trying to form 3-letter codes. So there will be 3 places to fill up. Now there are 10 English alphabets you are trying to make use of. So the first one is, no letter can be repeated. So if I select the first position that I can do in 10 different ways because I have all the 10 options available. Now out of these 10 options, I have already used one. So I will be left with 9 different options for the second place. I will be left with 8 different options for the third place. So therefore, I can do it in 10 into 9 into 8, that is 720 ways. So therefore, there can be 720 different codes made out of 10 different English letters, 723 letter codes that can be made out of 10 different English alphabets, given that the digit or the letters are not repeated. Now let us take the same idea if I am repeating the letters. So in that case, what happens? I am free to choose any one of the 10 in all the 3 places. I can select any one of the 10 letter in all the 3 places. So therefore, I have 10 into 10 into 10. There are 1000 ways of doing the same thing if I am allowed to repeat the letters. So therefore, this is exactly what I have written. Now let us move to example 2. Example 2. How many 4-digit numbers can be formed in which all the digits are different? Fine. All the digits are different means I am not allowed to repeat the digits. I have to ensure that the digits are not repeated. So in that case, let us consider these 4 placeholders. Now these placeholders are meant for all those 4 digits that I am going to put. Now in the first place, how many ways I can put the digits? Now you see there are 10 digits available, but in the first place I can't put 0. If I put 0 in the first place, it becomes a 3-digit number. So therefore, I have 9 options available. So out of 9 digits, I can put any one of them. Now in the second place, see, once I have put one of the digit in the first place, so I have one option less. So how many options I have? I have 8 options. But now I can put 0 also here. So therefore 8 plus 1, it becomes 9 options. So therefore in the second place I can put 9. Right? Then next onwards, so I had 9, I can choose any one of the 9. Then in the third place I can choose any one of the 8, and in the final place I can choose any one of the 7. So therefore, the total number of ways I can make a 4-digit number out of all the digits with no digits repeated, that is 4, 5, 3, 6. Fine. Number 3. Now there are room full of questions here. So to explain all of them, let me just explain a few, and then we will be just showing you the answer. You can do it all by yourself. See here, the first one, every digit is either 3 or 7. So if every digit is either 3 or 7, so that means what? I have only 2 options to fill. Now between 99 and between 1000, both excluded, that means I am talking about only 3-digit numbers. So I have only 3 positions to fill, and the first question is saying every digit is either 3 or 7. So therefore in all the places I have got option of putting only 2 options. So therefore 2 into 2 into 2, that is 8. Fine. Next, there is no restriction. Now if there is no restriction, so in the first place I can make use of 9 different digits. In the second place I can make use of 10 different digits. In the third place also I can make use of 10 different digits. So 9 into 10 into 10, that is 900. Right? Next, no digit is repeated. No digit is repeated, then in that case, first place I can select any 9, then in the second place another 9, and in the third place 8. So 9 into 9 into 8, that becomes 648. Next, the digit in hundreds place is 7. The digit in hundreds place is 7. So if I have the digit in hundreds place as 7, So what is happening? In the first place, I can't put anything because I have already fixed this place with one digit, that is 7. So I can make use of the other two places. I can put different digits. So that is, I can use 10 here, I can use another 10 here. So therefore, that is 100. Right? Sorry for the disturbance in the background. Okay, there's a construction going on, so there's a lot of sound coming. Anyway, now in case of the digit in the tens place is 7, if you just follow the same logic, you will get the answer. So I'm not going for doing that. Let us now go to the question number 6, where the digit 7 does not appear at any place. So digit 7 does not appear at any place. That is the idea when in the first place I can put how many digits? I can't put 0, and the question suggests that I can't put the digit 7. So I have 8 options here, right? Then in this case, in the second place, I can put 0, but I can't put 7. So therefore, I have 9 option. Same here also, 9 option. So therefore, it becomes 648. Fine. Now the digit 7 in the units place, same way. Now let us move to question number 8, the last one. In the last one, at least one of the digits is 7. Now this requires some attention. Now I am trying to make you understand how addition principle works. Now this is a question of addition principle, of course. So therefore, see, if at least one digit is 7, so that means what? There can be 1 7 at any one of the places. There can be 2 7s, and there can be 3 7s. So there are 3 different cases. This is one case, this is another case, and this is the third case. Fine. So therefore, if this is the case, so let us see how I can make use of these 3 different cases. So let us take the first case. First case is if I have the case of 1 7 at any place. So therefore, let us take 7 in the first place. So the first place is booked. I can't put any number in the first place, but in the second place and the third place, I can put any number but not 7. So therefore, how many options are there? There are 9 options here, there are 9 options here. So 9 into 9, there are 81 different options, right? Then next, if I have 7 in the middle and I have 2 places left, now I can't put anything here. I have to put different digits here. So now you see, in the first place I can't put 0, and as well as I can't put 7. So therefore I have 8 options. But in the last place I can put 9 different digits except 7 anything. So therefore there are 72 options. Now similarly, if I have only 1 7 in the last place, so again there are 8 options in the first place and 9 options in the second place. So 8 into 9, that is 72. So therefore, what did I get? I get how many different ways I can have a 3-digit number with only 1 7 present in the digit. So there are 81 plus 72 plus 72. So therefore 225 ways. Clear? Then let us come to the concept of 2 7s. So if I have 2 7s, now let me just write all those 3 different criteria. In the first case, let me put the 2 7s in the first 2 places. So the first 2 places are blocked. I can only put any number of digit in the last place. So how many digit I can put? I can put any of the 9 digits, right? Now let us come to the second case where second sub case, let me just say, where the first place and the last place is booked by 7, so I can put only one digit in the middle. And how many ways I can do it? Again 9 ways, right? And the last case, when I have 2 sevens at the tens place and units place, I am left with the hundreds place. Now in hundreds place I can't put 0 and I can't put 7, so I can do it in 8 different ways, right? So therefore, how many total number of ways I can have a number containing 2 sevens? Okay, so how many ways I can have a number having 2 sevens at any 2 different places? That is 9 plus 9 plus 8, that is 18 plus 8, that is 26. Fine. And finally the last case is of 3 sevens. Now 3 sevens, there is only one option. There will be 7 in all the 3 places, so there is no other option. So there is only one option available, right? So therefore, what is the total number of cases where I can have at least one digit as 7 in any one of the places? That is equals to 225. That is the number of cases where I can have only single 7. Then I have 26, that is the number of cases where I can have 2 sevens, and 1, that is the number of cases where I have got only all the 3 places as 7. So therefore this is 252. So this is how the addition principle works. So why you can see I am adding all these numbers, because this is a different case, this is another different case, this is another different case, right? So always remember, when there are different cases, I am going to always add. If it is the same case, then I am going to multiply, right? So I have just done it the same way. I have just given you the answers here, so you can just tally the answer and you can check for yourself. And number 8 I have solved exactly the same way as I have explained. So just give it a look and try it for yourself if you understand. Now this is not the only way of solving. You can solve it in other ways as well. So this was just made in order to make you understand how addition principle works. Now let us move to question number 4. Similar question. I have done only the first part. How many odd numbers less than 1000 can be formed using the digits 0, 4, 5 and 7? So here also we are going to make use of the addition principle. Why? Because the question is asking how many odd numbers. It is not mentioning specifically that what kind of odd numbers it is looking for. That is a single digit, a 2 digit or a 3 digit. So therefore I have to account for all the different types of odd numbers. So therefore, what I am going to do, I am going to divide all the different cases in the way that how many different types of odd numbers are there. So let us see the first one. The first one is single digit odd numbers. Now it is pretty obvious that there are 4 options, 0, 4, 5 and 7. So how many odd numbers are there in single digit? Only 2, that is 5 and 7, right? Next, 2-digit odd numbers. Now how many 2-digit odd numbers will be possible? See, if there are 2 places to fill, the last place can be filled in 2 different ways. Why? Because there are only 2 odd numbers, 5 and 7. And the first place can be filled in 3 different ways. Why? Because 4, 5 or 7, I can put any one of the 3 numbers. I can't put 0. So therefore 3 into 2, that is 6. Fine. And then 3-digit odd numbers. Now 3-digit odd numbers, again I have to fill 3 different places. The last place will be filled by any of the 2 numbers, that is 5 or 7. Now the first place can be filled by 3 numbers, that is 4, 5 or 7. And the middle place can be filled by any one of the 4 numbers. So 4, those 3 into 4 into 2, that is 24. So therefore the total number of odd numbers possible with digits repeated, that is 2 plus 6 plus 24, that is 32. I hope it is clear. Now let us move to number 5. Before that, let us move to the next topic, that is the factorials. Now factorials, it is a very simple and humble topic as it seems, but definitely there's a lot to it. So we are going to keep our discussion limited to the syllabus or to the area, the scope we have, because factorials in itself is a huge topic. So now, what is factorial? Basically, factorials are defined for natural numbers, and it is denoted by an exclamation mark after the natural number or like an angle bracket in front of the natural number, and it is defined by the product of all the natural numbers up to that particular natural number. Fine. So for example, if I take 5 factorial, so 5 factorial is basically 1 into 2 into 3 into 4 into 5. So you multiply all the natural numbers up to 5. If this would have been 100 factorial, so I would have had to multiply all the natural numbers up to 100. Fine. So here the answer is 120. Anyway, so now with this we define 0 factorial as 1. Now why we do this? Because 0 factorial is something which we require in our calculation, and by the definition of factorial, 0 is not a natural number, so we had to assume it separately that 0 factorial is 1, and later on we can prove that why 0 factorial is 1. There is a particular proof to it, that's how 0 factorial becomes 1. We are going to do that in a little bit. So now let us see some example. I already gave you examples. So 1 factorial is 1, 2 factorial is 2, 3 factorial is 6, 4 factorial is 24, and so on. Now if I look into the factorial from the other side, so I can write n factorial as n into n minus 1 into n minus 2 like this from the other side. So this is basically writing 5 factorial as 5 into 4 into 3 into 2 into 1 like that. So I can do it from the other side. So now if I check this much, see what is this? This is basically 1 into 2 into up to n minus 1. So this is basically n minus 1 factorial, right? So therefore I can write n factorial as n factorial is n into n minus 1 factorial, right? Now using this particular criteria, if I just go on checking, then 1 factorial can be written as 1 into 0 factorial. That is 1 factorial is equals to 1 into 1 minus 1 factorial. So therefore from there I can say directly that 0 factorial is 1. Why? Because 1 factorial value is 1, we already know. And 1 into 0 factorial, so 0 factorial can be written as 1 divided by 1. So that becomes 1. Correct? And for the same reason, I can also show that negative numbers do not have a factorial. Now that is not true completely, it is partially true that not all negative numbers can have factorial, but there are certain negative numbers they do have a factorial, and also there are fractions which also can have factorial, but I told you that factorials in itself is a huge topic, so let us limit ourselves to natural numbers only, because rest of it is beyond our scope. Fine. And also any constant inside a factorial do not come out. So not only constant, even addition, subtraction, anything. So it's more or less like if I having 2x factorial, it really does not mean 2 into x factorial. No, it really does not mean. And you can see the example here itself, 2 factorial and 4 factorial. So 4 factorial is definitely not equals to 2 into 2 factorial. No, definitely not. So similarly, I can have like m factorial, if I have m factorial plus n factorial, it is definitely not equals to m plus n factorial. Same with minus, same with multiplication, same with division, all of those things. Okay, So now let us move into examples. So the first example, now there are series of examples here. You can just go through them and you can solve them all by yourself. Let me solve few and we will be just giving you the answers. Now to solve, let us take the first one, 6 factorial. Now 6 factorial is straightforward, you can do it all by yourself. 4 factorial plus 3 factorial, find the factorials and then add them up. Now factorial of 9 minus 6, so 9 minus 6 is 3, so you are basically trying to find out 3 factorial. 6 factorial minus 4 factorial, same way. 3 factorial into 5 factorial, you will be doing the same way as well. So let us take question number 6. So from question number 6 onwards, we need to solve. Now question number 6, this is given 88 factorial by 86 factorial. Now 88 factorial can be written as 88 into 87 into 86 factorial. And similarly, we have 86 factorial. So 86 factorial gets cancelled. You will be left with 88 into 87, now whatever the value comes out to be. Fine. Next, 12 factorial by 10 factorial, 2 factorial. Now 12 factorial can be written as 12 into 11 into 10 factorial by 10 factorial into 2 factorial. So 10 factorial gets cancelled. Now 2 factorial is basically 2. So this and 12 cancels, so it becomes 6. So therefore your answer is 66. Right? Now let us take number 8. 9 factorial minus 8 factorial by 7. Now you can do the simple thing, that is you can just find the values and you can calculate, but without finding the value also you can do it. See, 9 factorial and 8 factorial, in both the cases 7 factorial is one of the factors of both. Now if you take 7 factorial common out of 9 factorial, you will be left with 9 into 8. And if you take 7 factorial common from 8 factorial, you will be left with only 8. And in the denominator you already have 7 factorial. So this 2 gets cancelled. 9 into 8 is 72. 72 minus 8, that is 64. Right? So without even calculation also you can do it, means using the calculator. Fine. So now I have just put them, I have listed all the answers here. You can just check for yourself all the different answers. Oh my goodness. This should be n plus 2. This is n plus 2. My mistake. Anyway. Right. Now let us move to question number 6. Question number 6. Which of the following are true? Which of the following are true? Obviously. Now the first one, 4 into 3 factorial is 4 factorial, which is obviously true. Now in the second case, 3 into 4 factorial is factorial of 3 into 4, which is definitely not true. I just discussed. Same with number 3 also. If you add the factorials, the addition doesn't go inside. Same for minus, same for multiplication, and also for division. So only the first one is true, rest all are false. Number 7. Convert this into factorials. Now converting this into factorials, you have to ensure that this the expression which is given is reduced down into factorial. Now with factorial there can be other things as well. It is not like that the whole thing has to be in factorials, but at least there has to be one factorial notation or one factorial number should be involved. Now you can see all these are multiples of 3, so I can do what? I can take 3 common from all the numbers. Now remember, they are not in plus. So when you are taking 3 common from a multiplication, all those 3 gets individually out, means you can take out. So therefore, it becomes 3 to the power 6. And then whatever is left is basically 6 factorial. So this becomes 3 to the power 6 into 6 factorial. Fine. Last problem. Find the value of n in the following equation. Now these are all factorial equations given. You have to find the value of n. Let us take the first one. Now obviously n plus 1 factorial is given 20 into n minus 1 factorial. Now how you can solve it? N plus 1 factorial can be written as n plus 1 into n minus 1 factorial. Now on both the side you can cancel n minus 1 factorial, so you are left with n square plus n equals to 20, or that gives you n square minus n square plus n minus 20 equals to 0, a quadratic equation. Solve it, you get this n plus 5 into n minus 4 equals to 0. So the value of n becomes minus 5 or 4. But remember, n is a natural number, because either if it is not a natural number I can't find the value of I can't have a factorial, so therefore the value of n is 4. Right? Second one, 1 by 5 factorial plus 1 by 6 factorial is equals to n by 6 factorial. So that is basically, if you take common LCM, 6 factorial is the LCM. So if you take 6 factorial as LCM, it becomes 6 plus 1, that is 7. Right? So simple enough. Go through the exercise, solve it. I hope you will understand, and if you have any doubt, get it clarified. Thank you.